In the previous case, sir.
Okay, you do recording. No problem. Watch recording. Huh?
Okay,
Let
sir.
me carry on. Huh? I explained everything. Better you have to put effort. Huh? Okay, no. Read this question. Something you see maximum elongation, maximum speed of the block. Okay, there's the initial. See, maximum, the basic fundamentals of a given problem, I will cover it. Maybe somewhere here you didn't made observation, you are unable to get that particular point. Better think once again, no, you'll get it, because same thing content repeating 5-6 times, I think will kill other students' timing. That is the reason why I'm avoiding it. Huh? That's why I'm asking you to be attentive in the class. When teacher explaining only, you should analyze everything very crystal clear. Huh? Okay, now there's initially it's a test. And what is the state of spring? Relaxed. Now I'm going to pull this. What actually happens here? Maximum elongation, maximum speed. So now you are already we are discussed. It's not something. This is a new thing. So very next moment. So here we'll get a situation like this. There's a force, and the spring will get elongated, kx1, and the block will acquire velocity, say v1. What is the reason here? It will start accelerating. No? The spring force all of a sudden will become not high value. Gradually, the spring will get elongated. The spring force will increase gradually. Still, if you go and check it, it will be less than applied force. So definitely net force is towards right. The body will accelerate, speed will increase. Then further sequence. So as because of velocity, the block. What is the next sequence? Here S. It is having the maximum elongation. I'll call kx naught. Not maximum elongation. Here the net force will be 0. It's in equilibrium. This will have maximum speed. Now you can straight away object it. Sir, how come you can say this is the maximum speed? I'll give one more thing. A very next moment. Already I discussed, okay, here's kx2. So definitely here f equal to kx naught. What is x naught? How do we measure x naught? We do measure with respect to this one. From here is what we'll measure all the length, no? No. This is a very basic fundamental. I'm telling this one really very essential. So now what is the state of the block? Here spring force balances the applied force, the net force is 0, then the block is at a maximum speed. Very next moment, now this spring force will be greater than F. The block will undergo retardation. It will have velocity like this only. The block is undergoing the retardation. The speed of the block start decreasing. Then, so finally at one position, it will come to instantaneous rest. So now I'm going to call this as maximum elongation. So till here acceleration, then afterwards retardation. So here it was acceleration. So many things. So where is the maximum speed? Maximum speed is at equilibrium. What do you mean by equilibrium? Or mean portion net force should be 0. So F equal to kx naught. This is the mean portion. When you apply external force, this will become mean portion here. Now maximum elongation is asking to get this one. And maximum speed is asking to get this one. Okay, how to calculate first this maximum elongation? What was the state of this rest? This will be instantaneous rest. Normal contact, it will like perpendicular displacement, weight will like perpendicular displacement. Who is the only force? What are the forces doing work? Applied force and spring force. So let's apply the work energy theorem. Initial kinetic energy, work done by applied force, work done by spring, equal to final kinetic energy. Initial kinetic energy 0. Work done by applied force F into X. Work done by the spring force. Spring force does negative work. Okay, there's a maximum elongation. Okay, how to get that maximum speed? We know F equal to Kx naught, no? There's an equilibrium. This force does work. Spring force does work. There'll be kinetic energy. Applying work energy theorem, initial kinetic energy, work done by spring equal to final kinetic. Initial kinetic energy 0. Work done by applied force F into X naught. Work done by spring. Let me write directly equal to M Bm square by 2. What is X naught? X naught we know F by K. Substitute this and solve. You'll get that maximum speed. Vertical spring block, already explained. The same thing is what I am bringing again here. Sir, I'll apply a variable force. Okay, then here what you're going to do? You're going to integrate no F into dx. Fine. How that force F equal to F naught x. Okay, put that F equal to F naught x here, then integrate. So then in that case, what you should write? Integral of F dx. Please base analyze here. Here only you have to analyze. If a constant force acts, force into displacement, variable force acts, then we are going to here also take integration, we'll manage. I think let's not bother like sir, there's a variable force, anything new will happen. Some mathematics will change here. Here also. The integration will come into picture. I think you know naturally work done topic we have done. Constant force acts, force into displacement, variable force acts, you're going to integrate. First work done by this applied force for small distance dx, then for a displacement of x naught, how much of work done. Okay, you may end up problems of constant or variable force. Just stick on to when external force acts, work energy theorem. Only spring force and weight are acting, conservation of mechanical energy.